In this video we're going to work on adding and subtracting rational expressions. There's two videos that I'll have on this where you have unlike fractions, which basically means you do not have a common denominator. You need that common denominator in order to add or subtract fractions. If you look at our first example, our denominator here is a 3x, and then we have a 2x cubed. So obviously they're not the same denominator. So what we're going to work on is creating a common denominator through multiplication. First, let's look at the 3 and the 2. If we can think of what's the lowest number that a 3 and a 2 will both fit into, we'll come up with 6. So what can we do to make both denominators equal to a 6? The fraction on the left, we can take this one and multiply it by a 2. 2 times 3 is 6. Well, if I'm going to multiply the bottom of my fraction by a 2, I have to make sure to multiply the numerator by a 2 also. That's what keeps everything even in a fraction. Now the fraction on the right, I have a 2, and again I'm trying to get this up to a 6, so I will take that 2 and multiply it by a 3. But if I multiply the denominator by 3, multiply the numerator by 3 also. Alright, so what we're doing is we're kind of building up our denominators so that they're the same, a common denominator. The next thing we need to look at are the x's. Here we have an x to the first power, so just one x, and here we have x to the third power, 3 x's. So what do we need to do so that we have the same number of x's on both sides? We can take on the left fraction, if we take this and we multiply it by an x squared, now I have an x times an x squared, which would give me that same x cubed. If I multiply the denominator by x squared, multiply the numerator by x squared also. Alright, so this is kind of looking like a mess, so let's rewrite what we have. In our numerator we have a 2 times a 4 times an x squared. So that's going to give us 8x squared. Over, our denominator is a 2 times a 3 times an x squared, which is 6x cubed. Now right now it might be tempting to try to cancel some of these x's, or maybe the 8 over the 6, but remember we want these denominators to be the same, so we need to keep everything as is right now. Minus, now on the right we have a 3 times a 2x, which gives us a 6x, over a 3 times a 2x cubed, which is 6x cubed. Alright, so we just worked on getting a common denominator. We can see that common denominator is 6x cubed. So when we do the subtraction, we know that this is going to be a 6x cubed down here. Now the numerator, what we're going to do is we're going to take this 8x squared and we're going to subtract a 6x. Now when you're working with all these x's, you want to make sure that you have like terms before combining those. So 8x squared and a 6x, those are not like terms, so we're going to leave those separate. We're going to have an 8x squared minus a 6x, all in the numerator. From here, we want to try to do any reducing of our fraction that we might be able to do. We do that with factoring. If we can factor anything out front, maybe we can cancel some things away. That numerator has an 8x squared minus 6x, so we could take a greatest common factor out. We could factor a 2 out of both terms and an x. That would leave us with a 4x minus 3 over the 6x cubed. Alright, so the last thing we're going to be able to do is, now that we factored that 2x out front, we can reduce the 2 over the 6 and the x over the x cubed. So that 2 over 6 reduces to a 1 over a 3. And that x over the x cubed, this x right here is going to cancel away an x from down here. I have 3 of them, so if it cancels one away, it's going to leave me with x squared. And then the other thing we have in the numerator is that 4x minus 3. So at this point, that 1 out front, maybe not necessary, so we could just say 4x minus 3 over 3x squared. So if you remember, it might be tempting to try to cancel these 3's right here, but when you have addition or subtraction, that keeps your terms together. So this 3 is connected to the 4x because of that subtraction. You can't cancel those separately. So that will be our final answer on this one. Alright, moving up to this next example. You do not have a common denominator. We have the x squared plus 2x minus 8 and then an x minus 2. Now in order to figure out what our common denominator might be, we want to go ahead and do any factoring of the denominators that we can. This x squared plus 2x minus 8, we can factor this. Factors of negative 8 that add up to 2, x plus 4, x minus 2. And maybe I'll go ahead and just cross that off because I'm going to use this new denominator down here. So I'm going to compare this denominator, x plus 4, x minus 2, with this one, x minus 2. Now that we have this factored, you can see that there is a common factor between the two fractions. You have an x minus 2 and an x minus 2. So the fraction on the right, what do we need to put over there in order to give us a common denominator? Well, the one on the right is missing the x plus 4. So we'll go ahead and multiply x plus 4 over here. We'll want to go ahead and throw parentheses around that x minus 2. And then remember, if you're going to multiply the denominator by x plus 4, we do want to multiply the numerator by x plus 4 as well. Alright, so let's rewrite our fractions and see where we're at here. We have an x squared plus 4x over x plus 4, x minus 2, plus, now, this 8x plus 4, you want to go ahead and distribute this because we know that we're going to end up combining all the terms of our numerators. So let's go ahead and distribute that, and we'll have an 8x plus 32 all over x minus 2, x plus 4. So even though these x plus 4, x minus 2 are in a different order, it's still the same numerator, or same denominator, so we're okay. Alright, so we add these fractions together. We know that our denominator is going to be x plus 4, x minus 2. Common denominator stays the same. Now we're going to go ahead and add these two numerators together, and we're going to combine like terms as we do that. Our x squared, if you look at the rest of the numerator, we don't have an x squared to go with that, so that'll just stay as x squared. Our 4x, we can go ahead and combine with the 8x, so 4x plus 8x is 12x. And then the last thing we have is that plus 32. Alright, so we had to do the legwork of getting a common denominator. Then we got our common denominator, we added the two fractions together. Now we're looking at this lovely fraction down here. Next thing you might want to do, or that we do want to do, is see if we can do any simplifying of this. So if you can do any reducing, we're going to see that in after we factor. If we factor that trinomial, x squared plus 12x plus 32, factors of 32 that add up to 12, a 4 and an 8, so x plus 4, x plus 8, over, we have our x plus 4, x minus 2. So now that everything's factored, it's a little bit more clear to see what's going to simplify and cancel away for us. So these x plus 4s are gone, and you're left with x plus 8 over x minus 2. And then remember, we can't cancel the x over the x or the 8 over the 2 because the x is connected to the 8 through the addition and it's connected to the 2 through the subtraction. So this will be our final answer on this one.